All right, we're going to look at a couple of questions from 2.8 in Alex. So the first one we have here is number 10. So again, a big part of this algebra function is understanding notation. So here we have a function, it's f plus g. So really it's found by taking f of negative 3, because again that's our input, plus g of negative 3. So we're going to use our function given to us as these sets of points to evaluate that function. So there's nothing to actually plug in and calculate, but to look and see where this fits in to the function. So f of negative 3, I'm going to look and see where I have an input of negative 3 in function f, which is right here. It outputs a negative 9. So f of negative 3 is negative 9. For g of negative 3, we go to the g function, and again we're looking for an input of negative 3, and that gives us an output of negative 1. So we'll have a negative 1. So negative 9 plus negative 1 is negative 10. So the value of our function f plus g of negative 3 would be negative 10. For number 11, again, very similar. It's giving to us the functions given as a set of points. This time the operation has a little dot. So remember there's going to be a difference between a little dot and an open dot. The little dot is multiplication. So really similar to what we were just looking at, but instead of addition, we're going to multiply. If you see an open circle, that's composition. That's when you have to do the substitution and then another substitution kind of thing. Okay, so again, this really means f of negative 5 times g of negative 5. That's what this new function does. It multiplies f and g together. So f of negative 5, we go to my f function, and I want to see what happens when I have an input of negative 5, which is negative 3. So f of negative 5 is negative 3. And we'll say times. Now let's figure out what g of negative 5 is. So I go to my g function. When I have an input of negative 5, it outputs negative 2. So I'm going to multiply negative 3 times negative 2 to make positive 6. So f times g of negative 5 is a positive 6. All right, for the last one, question 15. Now you can see that difference here, this open circle, that's composition. And this time, instead of lists of points, we are actually given equations of a variety of functions. So what we want to do is evaluate the composition when x is equal to 2. So that's what it tells us in our directions. And you can see it written here. And remember, composition is like a substitution of something into something else. And so the way I like to read this is, okay, negative 2 will have to go into h. Whatever I get out of that will then go into f. So I wrote it here in that kind of parentheses notation. So h of negative 2, here's h of negative 2, means go to my h function and input a negative 2. So h of negative 2 will be equal to 4 times negative 2 plus 5. This will be negative 8 plus 5, which will be negative 3. So now we take h of negative 2, I'm going to replace that with negative 3, because h of negative 2 is negative 3. So then I'm going to take f of that negative 3. So that's telling me I need to go to my f function, which is this first guy, and plug in a negative 3. So f of negative 3 is equal to, we'll take negative 3 to the third power minus 9 times negative 3. So negative 3 to the third power is negative 3 times negative 3 times negative 3, which will make negative 27. Then we have negative 9 times negative 3. That turns into a positive 27. We actually end up with 0. So by doing that composition, again, negative 2 plugged into h, that got me a negative 3. Then I took negative 3, plugged it into f. My final output is 0. So my answer here would be 0. So I hope that helps.